That's right.
Brian.
Thank you. Thank you. So, as I suspect most of you know, you are a very unusual audience, an unusual group that would come out in this enthusiastic way in support of science. I mean, most of the world doesn't see science in that way. Most of the world doesn't see science as a story, right? Most of the world sees science as this collection of facts that they were forced to learn at some point in school and then spit it back on an exam, and they were all too happy to leave it behind after the exam was over. But of course, what could be more human than science, right? Science is about asking questions and observing, exploring the world to try to find the answers. And that's what we do, right? That's what we do since we are even little kids, right? There's so many stories that get that across, but let me just give you one to get things going. So, my son, he's somewhere out here. He's 8 years old, somewhere out there. There he is, right there, yeah, good. Thank you. So when he was about 4.5 years old, I was telling him a lot of bedtime stories, and I was really trying to put some science into the stories, right? So I'd have all these spaceships flying through the universe, but I was always very diligent in saying they weren't going faster than the speed of light. One night, my son turns back to me and says, "Dad, speed of light? What about the speed of dark?" And it's like a thought I hadn't really had before. But you see, a young mind grappling with these kinds of ideas takes it to an unusual place. And just to be an equal opportunity parent, my daughter's also out there. And thank you, Sophia. Good. And, I have, for the last few years, been thinking about ideas that are unfamiliar to most people, the possibility of other universes, the multiverse. I mean, most of us were raised to think universe means everything to begin with, so how could there be other universes? And I say most of us with some forethought because my kids have heard me talk about this stuff all the time since they were really young. And Sophia, when she was 3.5, I was holding her one day. I said, "Sophia, I love you more than anything in the universe." And she turned back to me and said, "Dad, universe or multiverse?" Now that's how we begin, right? We have these open minds trying to understand everything in the world around us. But as we get older, right, we begin to deal with uncertainty. Like what Feynman was saying, how do you deal with a universe that you don't really understand? How do you deal with cutting-edge ideas that you don't even know if they're right or wrong because they're at the forefront and we haven't been able to test them yet? And I got a taste of how different people deal with that when I wrote The Elegant Universe back in 1999. It came out, it appeared on Amazon, and as you all know, Amazon is this wonderfully democratic approach where anybody can write a review of a book that they've read or haven't read. So a few days after the book appeared, somebody wrote in and gave it 5 stars. I was happy, that was good. And then I read the review, and they said they were so happy that someone finally had written a book on string theory that was accessible, because they said it's so hard to criticize things you don't understand. And they went on to say that after reading the book, they felt string theorists a bunch of mathematical buffoons chasing their own tails, and finished by saying that the reviewer felt that the author, namely me, seemed to be about as happy as a pig in shit. And what the reviewer was trying to say is, when you don't know if ideas are right or wrong, as it is with some of these cutting ideas about string theory and other things, there can be a deep level of uncertainty. And how do you deal with it? Feynman found it invigorating. Others find it deeply uncomfortable. And that is a wonderful divide in terms of how one goes about exploring the universe. Okay, now for my story. In my final 2 minutes. I got 2 minutes left, right? Okay. So one quick story, a kind of personal story, not that personal a story, but a story about discovery. I mean, what we scientists live for are the rare moments when it all works, right? We're doing a calculation and it all comes together. And this example is one that comes from 1990s, 1992 or so. I was at the Institute for Advanced Study at Princeton. And I was working with a couple colleagues, Dave Morrison, who's normally at Duke at that time, Paul Aspinwall, who's now at Duke as well. And we wondered whether in string theory the universe might evolve in different ways than it could in Einstein's general theory of relativity. Right? In general relativity, we all know that space can stretch, it can expand, it can twist, it can warp. But one thing that can't happen in Einstein's general relativity is space can't tear apart and, say, repair itself. That tearing process would yield to physical phenomenon that would be disastrous, and the mathematics doesn't allow it to happen. We asked whether in string theory space might actually rip. So we broke this problem into two parts. Dave Morrison and I tried to work out the mathematical calculation that would give us insight into whether or not this tearing process could happen. Paul Aspinwall was working on the computer code that was going to implement these mathematical ideas and do the final calculation to see whether it was possible. And we phrased the calculation in terms of a physical parameter. You can think of it as the mass of a particle. We asked ourselves, if space ripped, would the mass of that particle smoothly change, or would it abruptly change in a way that would establish that that process was discontinuous, couldn't happen? So Morrison and I, we spent months working out the mathematics that needed to be plugged into the computer program. Paul had finished the program, was waiting for our results. It was a Friday night in the Institute for Advanced Study, quiet, right? It's a very quiet place at night. And we finished up, and we wanted to put it into the computer program. So Paul, who'd already gone home, he called him up and said, Paul, can you come back? You know, we finally got it. We can put it in, and we can hit the button and see whether this happens. And Paul said no. It was Friday night, he wanted to watch TV, and he wasn't going to come in. He said it can wait until Monday. So we said, Paul, will you come tomorrow morning? He said, look, the only way I'm going to come tomorrow morning is if you buy me a six-pack of beer, and it's waiting there for me. We said, okay, it will be waiting. So he came in the next morning, put in our result into his computer program. We all huddled around the terminal, and Morrison hit the enter button. And what we were looking for, what we boiled it down to, is if it came out, it sort of sounds like Douglas Adams, so it's not, if the number 12 popped out, this is real, if the number 12 popped out of this computer calculation, it meant that space could tear in string theory. So we huddled around, he hit enter, and instead the number popped out was 3.99999. And we're like, oh God, it didn't work. But wait, we said 3.999. It's so close to a whole number. Maybe it's just a round off. I remember it's really 4. And maybe we just lost a factor of 3 somewhere in the calculation. So we go back to the calculation. We put it up on the board. Lo and behold, we find the missing factor of 3. We put it back in, hit the enter button again, and out it comes 11.999999. That's the round off to 12, and it worked. And at that moment, I just ran around the office because we were looking at something that nobody else had seen before. We were looking at evidence that if string theory is correct, that space could tear apart and repair itself in a way that Einstein's ideas would not allow. It was this thrilling moment to look at this new phenomenon coming out of this research. And that is really what science is about. It's those moments where you're looking at reality and you're peeling away a layer that nobody else has been able to peel away before. And it's my strong feeling that we scientists, look, we have those moments rarely, a few times in a career maybe. But if kids could even have a small glimpse of that, even by solving problems that we know already have answers, but that moment of going from confusion to clarity, that transition is what science is, and that's what makes it exciting. And if only more kids would have that experience, I just think it would change the world. Thank you very much.